This lesson is for XEI 302. Our focus skill for today is to solve one-step equations that involve answers with integers or decimals. So I'm going to begin here actually with some review. We're going to start with the distributive property. Now this is something that I'm sure you've practiced before, but let's just go through and make sure that we have all of these skills down so that when we get to some of these equations, it will be a pretty easy transition for us. So let's start with 1a here. When we see this 4 outside of the parentheses, we want to distribute this 4 to both terms. So we're going to take 4 times z, which would give us 4z. Then we take the product of 4 and 2. So 4 times 2 gives me 8. I like to show these little arrows. I call them rainbows sometimes, just to draw those in so I remember I'm doing both of these terms. So my final answer actually is 4z plus 8. These are not like terms, so I can't add them. So these are not like terms. So I leave it as 4z plus 8. Now in the second question here, 1b, the 2 is actually following the parentheses. But remember, in order of operations, when you multiply, it doesn't matter if you do 2 times 3 or 3 times 2, these both give you the exact same value. So I can mix the order that I multiply something in. So that's what I'm going to do here. I'm just going to take that 2 and I'm going to rewrite that 2 out in front. So sometimes that might help, guys, so that you don't get a little confused on that. So now I'm going to take that and distribute to both terms here. So I have 2 times 6y. 2 times 6y is going to give me 12y. Then I'm going to take the 2 and I'm going to multiply it by negative 4. This is going to give me a negative 8. Now sometimes people will see that and do 2 plus negative 4 in their head, so they can make some mental errors here. So make sure you're using your calculator and always typing in multiplication here. 2 times negative 4. Alright, and that final answer here would be 12y minus 8. Remember, I can't simplify any further. 1c, this time I have a negative out in front. When I distribute this negative, the first term here is going to end up being negative 8x. Negative 2 times 4x gives me negative 8x. When I take negative 2 and multiply it by this negative 4, I also get here a positive because I have a double negative. So negative 2 times negative 4 gives me a positive 8. So in this question, it's really easy to forget to multiply by this negative here and write this as negative 8x minus 8. So you always got to remember you're distributing the negative to both parts. So make sure that you don't make that mistake here in the next question that you're going to try on your own. Alright, in 1D, this kind of confuses students too sometimes because they see this negative sign and they don't know what to do with it. Well, think of this as a negative 1. So whenever you see a negative sign outside of parentheses, it's really like having a negative 1. If we distribute that number, 1 times a doesn't change the value of a, but the negative will make that now negative a. So we have negative 1 times a gives me negative a. I could also write negative 1a there, and both of that just written like this, these would both be correct. Okay? So I'm going to erase the negative 1a though, and I'm just going to write negative a. And then I'm going to take negative 1 and multiply this by the negative 4 here to get a positive 4. So here's my final answer, negative a plus 4. I would like you guys to try these next 4 problems here, 2a through d. So you're going to try these questions through here, and then when you check in your answers, we'll check for accuracy and we'll go over those together. So go ahead and pause the video and try 2a through 2d. Okay, next up here is the topic of inverse operations. The word inverse in math is also equivalent to saying opposite. You can think of this as the opposite operation. Okay, so the word inverse, we're going to think of it as the opposite operation. So here in the first example, it says the opposite operation of addition. Well, that is subtraction. The opposite of adding something is to subtract something. The inverse operation of subtraction then would be addition. So the opposite operation, when you see that word, you can think of opposite. The opposite operation of subtraction is addition. The inverse operation of multiplication is going to be division, which means that the inverse operation of division is multiplication. So there's going to be a couple questions on your skill sheets like this here, these level 2 questions that say write the inverse of each operation. So when it says subtract 4.2, you're going to do the inverse operation, which would be to add 4.2. So that's actually all I need to do here. When it says multiply by negative 4, then I'm going to divide by negative 4. So I can use that symbol here, or I can show divide by negative 4 just like that. Either way is fine. To add 9, I can subtract 9. The opposite operation of dividing by 2 would be to multiply by 2. So we're going to use that idea now in part or in question 4 here, where it says to solve the equations, we're going to use the inverse operation in order to solve for the variable. So here when I look at number 4a, it says x minus 17 is equal to negative 10. I am going to add 10 because I have x minus 17, so I'm subtracting. I'm going to use the inverse operation, and I'm going to do that to both sides of the equation here so that I end up with x equaling a positive 7. In part b, I have negative 3.9 plus x equals 7. Now in this case, I actually want to add 3.9. I'm going to do the opposite here. I'm going to add 3.9 on both sides, so I'm doing the opposite of this sign. So because that's negative, I want to add 3.9. That'll cancel here, so I'm left with x equals 7 plus 3.9 gives me 10.9. So there's my final answer. So in your final answer, you can box your final answer, but you want to have x equals and then a number. That's your goal, is to always have one x. So notice how in front of this I could always put a 1 there, but I need to have x all alone. Now in part C here, I want to get x all alone, and right now it's attached to the x. So I think of that as being multiplied, right? There's a little invisible dot here where that really means negative 14 times x. So if we want to undo that, we're going to have to divide by negative 14 on both sides. That's going to cancel here. So a lot of times the incorrect way to solve this, most students will make the mistake and they want to add 14 here because they see the negative sign, but that's not the case. These are attached by multiplication. So to undo that multiplication, we do the inverse operation, which is to divide. So I'm showing that here with that division symbol here with the bar. So divide by negative 14 on both sides. Now this is something that you would put in your calculator. So 290 divided by negative 14 gives me 20.7. So I have x equals 20.714. I'm going to just round to the nearest hundredth, so the second decimal here, and write my answer as 20.71. In number D, in part D here, here I've got x divided by a negative 12. Now I'm going to attach that negative. It doesn't matter if I put it on the x or the 12. It's got to go somewhere though, but I'm going to put it in on the 12 here so that I can get rid of it at once. So if I'm dividing by negative 12, to undo that, I do the opposite operation, which with the inverse of division is multiplication. So I'm going to multiply by negative 12 on both sides. Now I can clearly cancel this out because negative 12 divided by negative 12 would give me 1, so those are going to cancel. Then I'm going to take 32 and multiply by negative 12 on the other side to get negative 384. So here I bring down my x and I end up with x equaling negative 384. Now f is sometimes a little confusing for students because here it has a 0 on one side and they don't know what to do sometimes with the 0. But what I want you to do is look at how the 2 here and the x are combined. You want to isolate x. You want to get x alone. Now to do that, we have to undo this 2 here, which is right now being multiplied by x. So 2 times x is what we want to undo. We're going to divide then by 2 on both sides. Now I can cancel those 2's out. I'm left with x equaling 0 divided by 2 gives me 0. So even though it might look confusing at first, just think of how x is being attached to the 2 and then try to undo whatever operation that is. So in part G here, where it says negative 8, x equals negative 3, I'm going to divide by negative 8 on both sides. Because right now, negative 8 and x are attached by multiplication, so I'm going to undo that by dividing. So please make sure you're not trying to add 8 to both sides because you get a totally different number if you try to add 8. So we have to remember we're doing the opposite operation, which is to divide by negative 8. So we end up with x equaling negative divided by a negative is going to give me a positive, and 3/8 is a fraction actually reduced in lowest terms, so I'm going to keep it as 3/8. If you stick in your calculator and you round to the nearest hundredth, you end up with 0.375, which will round up to 0.38. So I'd actually rather you, if the decimal is pretty short, I'd rather you just give me the whole decimal instead of rounding to the nearest hundredth, okay? All right, in H, this is the last one I'm going to do before you do some of these on your own. I want to solve for x again. Just because it's on the right-hand side shouldn't trip you up. If you needed to, you can rewrite the 2 on the right like this if you had to, but I'm going to keep it as it is. Remember, I can take that negative and put it next to the 6, and then to get rid of this negative 6 here, x divided by negative 6, we need to multiply by negative 6 on both sides. So this will cancel here on the right hand side, leaves you with just the x. So x is going to equal negative 12. So it's okay that I have the x on the right hand side, because of course I could always rewrite this equivalent equation here by switching x and negative 12. Alright, you guys are going to pause the video now and work on the you try section here. It's 8 problems. So 5A through D, or A through H I should say, sorry. These are the ones that you're going to try on your own, so pause the video, and you can look back and work on these problems, and they pretty much mirror problems 4A through H. So you can look at those and see how you solve those to kind of give you hints on these. So go ahead, pause, and then come back and play the video. Okay, next up we have fractions. So I know that these are dreaded sometimes by students, but really these aren't going to be too bad for us, because I'm going to show you a way to easily get rid of these fractions. So when you're dealing with a fraction here, see how my variable is attached to the 2/5. Now this is really 2/5 times x, okay? Or you could think of this as 2 times x divided by 5. Now if we want to undo this, there is a long way to do this, and there's a short way to do this. I'm going to show you both, and then obviously we're going to use the short way. So one of the ways that you can do this question here to isolate your x is to multiply by 5 first. Multiplying by 5 will leave me with 2x equaling 25. Now that I have the 2x here, I can divide now by 2 on both sides, so that I end up with x equaling 25 over 2. So it took me 2 steps here to do this question, to solve for x. Now the short way is to do something called multiplying by the reciprocal, okay? So we're going to multiply here by 5 halves, because multiplying by 5 halves actually cancels out the fraction 2/5. 5 halves multiplied by 2/5 is just 1. So it cancels here, that 5 and 5, the 2 and 2, and leaves me with x equaling. On the other side, I need to make sure I also multiply by the reciprocal. So sometimes students will just multiply on one side and forget to do it on the other, so make sure you remember both to do it on both sides. Put this right in your calculator. Stick the 5 in, and then multiplied by, in parentheses, 5 divided by 2. And you should end up with 25 halves after you reduce that fraction. And you can hit math enter in your calculator. Okay, so I get the exact same answer, like I said, with just one step. So here, when we are multiplying our variable by a fraction, we will always undo the problem by multiplying by the reciprocal. And that reciprocal, oops, I spelled that wrong. One more time. Reciprocal. Okay, there we go. Oh, it's spelled right here too. Should have looked up. Okay, so we're going to multiply by the reciprocal. Now the reciprocal, I know you know this word already, but I just want to review it. The reciprocal of negative 2/3 would be negative 3/2. We keep the same sign, but we just flip what's on top and bottom so that the fraction just flips upside down basically. Okay, so we're going to solve the equation here. In 6a, I want to actually multiply here to get the x by itself. I see a fraction. I'm going to multiply by negative 3/4 on both sides. So I multiply by negative 3/4 on both sides. This gets rid of the 4/3 here on the left-hand side, leaves me with a positive x equaling. On the right-hand side, if I multiply this, I get negative 30/4, which will reduce to negative 15 halves. So make sure that in your calculator you're reducing that fraction nicely like that. In part B here, 6b, here I have a divided by 5. You can think of this as 1/5 times a, but you know, since we know that this is dividing by 5, I'm just going to do the inverse operation here and just multiply by 5. So don't always, overcomplicate something. Just because it starts with a fraction doesn't mean that it's going to be hard. So we cancel out the 5s here, and I'm left with a equaling negative 11 times 5 gives me negative 55. In 6c, here I have the variable on the right-hand side, and I've got this negative 3/4 attached to it. So I'm going to multiply here by the reciprocal, negative 4/3. I do that on both sides. This is going to cancel here. That entire fraction leaves me with a positive 9 equals, on the left-hand side, negative 4/3. Make sure you put that in your calculator, multiply by 9, and you're going to actually get negative 12. As long as you input that fraction correctly, you should get negative 12 here. In D, I have 2/5 x equaling 4/5. Now, just because I have fractions on both sides doesn't mean that this problem is any more difficult than the last ones we did. We want to focus on isolating for x. We want to get x alone. So I'm going to multiply by the reciprocal here, 5 halves. I do it on both sides. This is going to cancel on the left-hand side. It'll leave me with just x. On the right-hand side, I simply put that in my calculator, so I make sure I put 4 divided by 5 in parentheses, and then multiply that by 5 halves, which is also going to go in parentheses. When I do that, I end up with just 2. So please go ahead and try these next you try questions, E through H. Go ahead, pause the video, and try these ones. Okay, next up we have our level 3 questions, our focus and context questions. So these are questions where you're still going to solve equations, but you're going to do it in context to a word problem or possibly a geometry problem like in problem 7 here where you're given a diagram. So here in problem 7 it says the perimeter of a triangle is 41. Find the length of the side marked x, so we want to figure out how long this side is. If we use the equation, 17 plus 9 plus x is 41. So what's nice is they already give you the equation that you're going to use. You don't even need to set one up for yourself. You're just going to solve for x here. So we have 17 plus 9 plus x equals 41. Now I can solve this equation 2 different ways. Since I want to get x alone, I need to move 17 and 9 to the other side so that I have x by itself. So if I do that, I can subtract 9 first, or 17. It doesn't make a difference which one I decide to subtract, but let's subtract the 17 first. So if I were to do that, I now have an equation that says 9 plus x because this is gone. Okay, so I have 9 plus x equaling 24 over here. And then I'm going to subtract the 9 one more time to get the x completely by itself, and I end up with x equaling 15. Now here I took a couple steps to do that, and it's not that it's wrong, but there is a little bit quicker way to do this question. So right away, when I see 17 and 9 here on the same side, I can actually simplify this and call that 26. So 17 plus 9 gives me 26 plus x equaling 41. So I can't move the 17 and the 41. I can't simplify that together, but I can simplify stuff when it's on the same side. So because 17 and 9 here are starting on the same side, that means I can simplify that to just 26. So now if I solve for x, I'm going to subtract 26 here, and I end up with x equaling, so those cancel, x equaling 15. So I get the exact same answer either way I do that question. Okay, number 8, it says Tammy walked home from school one day. She walked a total of 2.5 miles in 40 minutes. We're going to use the formula D equals R times T right here, where D represents the total distance, R represents the rate, and T represents the time. So the question is, what was the rate at which Tammy walked home from school in miles per minute? You're going to notice it's in miles per minute because the information they give us is miles and minutes. So we're going to use the equation that they tell us. D equals R times T. So D is distance, R is a rate, and T is the time. So let's go through and actually look at what we know. Well, 2.5 miles, the given distance here, is the D variable. So we have D equals 2.5. We also have that she walked this in 40 minutes. So that would be a time, right? Minutes is a time, so I'm going to write T equals 40. Now, R is what I'm looking for, and I know that because it asks me what was the rate. So when it asks me what's the rate here, that means I don't know R, so R is what I'm looking for. So I look over here in this equation, and if I want to get R by itself, I would have to get rid of the T. Now this is R times T, so to undo that, I need to I need to divide, right? It's being multiplied right now, so to undo that, I do the inverse operation, which is to divide, so I do that on both sides. The T's are going to cancel. That leaves me with D over T equals R. So now I'm going to substitute in what I know. I know that D is equal to 2.5, and T is equal to 40. So I take 2.5, and I divide it by 40 now to get R. Okay, so this answer ends up being 0.0625. So R equals 0.0625. Now the question says that your answer should be in miles per minute because this is a rate, right? Rate is always expressed like miles per hour, but this one is going to be in miles per minute. So I also need to consider the fact that it says round your answer to the nearest hundredth. Now that we worked on that skill, we know where our hundredth place is. So our hundredth place is actually right here. So if I round to the nearest hundredth, I'd leave it at 0.06 because I have a 2 here, so I don't round up, I keep it the same. So we've got 0.06, oops, and that's miles per minute. So this is the rate. So she walks at a rate of 0.06 miles per minute. Okay, that is the end of your first part of this lesson. We're actually going to do the extension skill here in a separate video. So you're going to pause this video, go back and look at all the questions that you're supposed to do on your own, and then go ahead and watch the extension skill video so that you can do the extension skills in your skill sheets, okay?